Okay, hello, this is 5-6, day 2, which is another different type of transformation, which is a reflection. And kind of layman's terms for a reflection is a flip. So we do have some rules for reflections. So these rules are going to be easier because they're the same no matter what, unlike in the last part of 5-6, we were making up our own rules. But the rules for an x-axis reflection, when something reflects across the x-axis, that would be, this is the x-axis, that means it flips from here to here or vice versa. So the only thing that's changing, the horizontal position isn't changing, but the vertical position is changing. So the x-coordinate is going to stay the same, but the y-coordinate is going to become the opposite. So I have a negative sign here, which means opposite. Okay, if something is to reflect across the y-axis, it's doing a flip this way and that way. So that is not going to affect the vertical position. It's only going to affect left and right. So in this case, the x-coordinate becomes the opposite and the y-coordinate stays the same. Okay, so the first one says graph the image of triangle ABC after a reflection over the x-axis. Okay, so here's our x-axis. This thing is going to rotate or flip. So we're going to follow the x-axis rotation rules. So the first thing I'm going to do is I'm going to write out the coordinates of the original points. So point A here is at 3, 4, 5, -5, +3. Okay. And then B is at 1, 3. And C is at -7, -2. Okay. The rule for an x-axis reflection, again, if I look here, is I'm taking the coordinates and I'm mapping them to x and opposite of y. Okay, so A prime, notice the x stays the same. So I'm going to keep the same x coordinate, which is -5, but I'm going to change the y coordinate to the opposite. And the opposite of +3 is a -3. Okay, so for B prime, same thing. I'm going to keep the x coordinate how it is, which is at 1, and I'm going to take the opposite y coordinate, and the opposite of +3 is -3. And for C prime, follow the same rule. The x coordinate stays the same, so I'm going to keep that a -7, and the y is going to become the opposite. So the opposite of -2 is +2. All right, so now I'm going to go ahead and graph these in pink. So -5, -3 is going to be here, and that is A prime. Now, you're going to notice that if I have a graph, that reflecting something across the axis is really as easy as counting how many units above or below the axis is and just moving it that same amount on the other side. So for example, from the x-axis, A is 3 units above it. So A prime would be 3 units below that x-axis. Okay, B prime is at 1, -3, which is here. And again, you're going to notice that B is 3 units above the x-axis and B prime is 3 units below. And then we have C prime at -7, +2. And C is 2 units below the x-axis, so C prime is going to be 2 units above the x-axis. Okay, so here we have the image reflected across the x-axis. It's kind of like the x-axis is a mirror, okay? It's a mirror image. Okay, so if we do not have the graph to just move it or reflect it over, we can always use those rules. So the rules for an x-axis reflection, again from the previous page, was we take the x and the y and we map that to x and then opposite of y. So B is going to become B prime. So for an x-axis reflection, again, we're going to keep the x coordinate the same, which is -6, and we're just going to change the y coordinate to the opposite, which is going to be a -11. Okay? For a y-axis reflection, the x coordinate is the one that becomes the opposite, and we keep the y. So let's go back to our original point. Our original point was -611. So if I follow the rule here, opposite of the x would be a +6, and the y stays the same, which is 11. Okay, so I don't need graph paper to be able to reflect it. I can just follow the rule. Okay, the next one says graph the reflection of quadrilateral ABCD across the y-axis. Okay, so what we're doing is when we reflect across the y-axis, here's our rule, we're actually multiplying that x-coordinate by a -1. That's another way to think about it. Okay, multiplying it by a -1 or just taking the opposite, same thing. So if I look here, we got to write down our original coordinates, 1, 2, 3, -4, and up 1. Okay, B is at -2, +1. Oops. Let's get rid of that. C is at -1, -2. And D is at -4, -3. Okay, so what we are doing then is we are basically taking the opposite of the x coordinate, right? So the opposite of the x, again, the original coordinates were -4, 1. So the opposite of a -4 would be a +4, and then we keep the y coordinate the same. Okay, here again, our coordinates were at -2, 1. If we take the opposite of -2, that'll be +2 and keep the y the same. Okay, original coordinates were -1, -2. We take the opposite of this one. So the opposite of -1 is a +1, and then we keep the coordinate -2 the same. And then same thing here, opposite of a -4 is a +4, and we keep this a -3. Okay, again, we can think about this as multiplying by a -1 every single time. So now our new coordinates, A prime at 4, 1, B prime at 2, 1, C prime at 1, -2, and D prime at 4, -3. Okay, so a reflection is the same as a translation in that you're going to get a congruent image. Okay, they should be the same shape and size. It's just that one is going to be a reflection, which means a flip or a mirror image of the other one. Okay, the last one says graph the reflection of triangle FGH across the x-axis. So again, there are several ways to do this. You could write down all the coordinates and use the rule, but I'm just going to use the fast method because I have the graph, okay? So reflecting across the x-axis means this is my line of reflection. This is my mirror. So to do this quickly, okay, F is 2 units below the x-axis. So that means F prime on the same line at -4 here is going to be 2 units above the x-axis. So this is F prime. Okay, so now H is at -2, and it happens to be 1, 2, 3, 4 units below the x-axis. So H prime is going to be 1, 2, 3, 4 units above the x-axis. And then G is 1, 2, 3 units below the x-axis here at 1. So G prime will be 1, 2, 3 units above the x-axis. All right, so it's completely acceptable for you to graph reflections this way. If I ask for coordinates and you don't have a graph, feel free to use the rule or use the rule either way like we did with this one. But again, if you just reflect something across the y-axis, you're going to find like B is 2 units to the left, so B prime is going to be 2 units to the right of that y-axis. So in this one, this was our reflection line or our mirror image line. Okay, please let me know if you have any questions on reflections.